Hello everyone, welcome to this video on the fundamentals of cloud computing. So if you want to learn more about cloud computing, this is a good place to start. First question, why cloud services, right? Why should we shift our services into the cloud instead of maintaining our own on-premise presence? Now, cloud services have certain characteristics and considerations, such as the ones listed here. So first, high availability. Now, high availability is the ability for business to continue when there is a downtime. So from the perspective of a data center infrastructure, at the very minimum, we're looking at doubling up every aspect of a data center. So redundant power lines, multiple racks comprising multiple servers with the ability to have duplicate instances of your workloads. Disaster recovery, the ability to recover from disaster. So your backup infrastructure, how your backups are saved, how are your backups implemented, fault tolerance, the ability for you to recover effectively when there's a fault, right? So what is your tolerance to fault and failures within your infrastructure? So typically when we discuss business continuity, we will discuss the term high availability, disaster recovery, and fault tolerance as part of the entire, or rather the complete discussion on business continuity. Scalability, the ability for your resources to scale up, down, in and out. What does that mean? Scaling up generally means adding more resources. So if you have a VM, you're scaling it up. It means that you are adding more CPU, virtual CPU, or you're adding more memory allocation. If you are scaling out, it means that you're adding multiple instances of a server so that you can distribute access to your applications across multiple servers, right? So typically when we use the term scale out, scaling, it means adding servers or even reducing servers. And that's one of the benefit of a cloud service, the ability for you to reduce your instances and only pay for the instances that you are using at any point in time. Elasticity is again the ability for you to expand on the resources that are allocated to your servers. So in the if I give you an example of elasticity on the cloud, if I look at database service, right, we are able to purchase resources and use the resources or spread the resources across multiple database instances. And you can also increase the capacity of the resource and reduce the capacity at any which point you want. Agility, the ability for you to bring resources in and out of cloud service, the ability for you to extract a workload from maybe an infrastructure service into a platform service and back and forth. So that kind of agility is something that customers greatly benefit from. A cloud service should also have the ability to reach or rather reach out globally. So me as a customer, if I want to a cloud customer, if I want to place a solution on Azure, for example, Microsoft should have data centers, in many parts of the world, so that if a customer, from a particular region want to access data, number one, data should be accessible. Number two, it should be accessible within as low latency as possible, right? So that's also something, a capability that cloud services should provide. Predictive cost, I have another video presentation on Azure pricing, and it pretty much shows you how and the tools that you can use to predict the cost of ownership on the cloud. So it's important for me to be able to get a clear understanding on what my resources are going to cost me on the cloud, so that I can make a calculated decision in moving to the cloud and operating my IT infrastructure on the cloud. Last but not least, security. Right? If me as a cloud service provider, if I don't have the ability to provide defense in depth, that means providing security at all layers, from the physical to the network to the operating system to the way my applications are hosted in my data center, then I'm not going to be able to provide a viable service to the customer, right? So these are the characteristics of a cloud service. So moving to a cloud service means that you get to leverage on these characteristics, which sometimes can be very expensive for us to implement within our local on-premise data center. And that takes me to the next slide, economies of scale, right? So the concept of economies of scale is the ability to do less, to do things less expensively and more efficiently when operating at a larger scale. The problem is that when we implement an on-premise data center, we may not have the ability to invest as heavily into a data center as cloud providers such as Microsoft, Google, Amazon Web Services, and so on, right? So they get to implement massive data centers operating at massive scale with loads of resources available for us to consume. At the same time, they're able to spend a lot on security and other supporting services as well. And they then pass on those benefits to the customers, which is us. Now, another term that is important to understand when we discuss cloud computing is Capex and OPEX. Typically, what is a capital expenditure? It is how much you are spending on your physical infrastructure. So typically, if you were to build your own data center, you need to spend a lot on physical infrastructure. Obviously, from the perspective of company expenses, you get to deduct the expenses from the tax bill, but it's still a very high upfront cost, and the value of your investment reduces over time. And typically, data center life cycle is about 5 years, and that means that after 5 years, there's no value to your data center, and you have to reinvest to upgrade your data center resources all over again, right? So it's still a recurring cost. And then we have OPEX, operational expenditure, and that is what you are spending on services and products moving forward. So if it's on-premise, labor costs, electricity or air conditioning, and whatever else, vendor costs and so on, all that is part of operational expenditure. Yes, you do get to deduct the expense from your tax bill as well. But from the perspective of the cloud, there's no upfront costs and you pay as you use. So typically, when we speak to customers and get them to move to the cloud, the idea is that you don't have that high upfront cost associated with a capital expenditure. And as you use your resources and services on the cloud, and because it's consumption based, you pay as you use, you only pay for what you use. So therefore, the cost of operating your environment on the cloud becomes cheaper over time as opposed to on-premise. Now, this is again a very general discussion. There are many cases that I've seen with customers where even moving to the cloud, when it requires migration and so on, it does entail a high upfront cost as well. But over time, your operational expenditure is greatly reduced. Right, so as I said earlier, cloud computing services are generally consumption-based. So you only pay for the resource that you use. An example, if you create a virtual machine on the cloud, most service providers, they will only charge you the cost of compute, which is the cost of processing your VM, the CPU cost and the memory cost, as long as your VM is running. So if you were to stop the VM, then you stop paying for compute charges. You only pay for storage because your virtual machine files are still occupying storage, right? So if you were operating a test and development environment on the cloud and you were to shut down your virtual machines at the end of your testing period, then you stop paying for compute. So it becomes extremely cheap for you to host some of these test and development environments on the cloud, right? So that is what consumption based is. From the perspective of applications, right? So we have many services in which you only charge as the service executes. For example, if I use a service like Azure Function or serverless computing, for example, or microservice-based application hosting, only when your application code executes, you pay for it, right? So if your application is not in use and the code is not executing, you do not pay for it, as opposed to hosting an application in a server. Regardless of whether your application is being accessed or not, your server has to run and you have to continue paying for the server. But the cloud models are a bit different, right? It's purely consumption based. So let's start looking at some of the cloud models that we have. So we generally have three: public, private, and hybrid cloud. So a public cloud is where the services are being hosted by a hosting provider. So in this case, we're looking at Microsoft, Google, Amazon Web Services as the hosting providers. So once you implement or create a resource on the cloud, then you're accessing it over the internet. The access is typically secure via HTTPS, or in certain cases even via a dedicated or direct or VPN connection to the cloud provider. Right? Private cloud is where you own and operate the cloud platform. Right? Microsoft has services like Azure Stack, which is Azure in a box. You literally purchase the Azure Stack system and run it out of your data center, and users will then access a self-service portal to provision resources into the hosting platform. In this case, you are responsible in the operations of the cloud service, right? So that is a private cloud. And finally, we have hybrid cloud, which is a combination of public and private or on-premise data center implementations, which allows you to run your applications in a hybrid scenario. A good example would be if you are a bank and you have regulatory or compliance issues against running hosting your data on the cloud, right? So what you want to do is that you want to maybe place your front end web services on the cloud, a public cloud, and you can then place your databases containing all the banking data within your own on-premise data center, right? Which is secured obviously within your boundaries. And when you then enable the integration between the web service on a public cloud and the backend database services in your internal data center, that becomes an example of hybrid operations. Right, so if you want to compare the three models, a very quick comparison. Public cloud, there is no Capex, you're not buying infrastructure. Even when you need to scale services up, you want to add RAM, you want to add virtual CPU, you want to add multiple instances of a server behind a load balance solution. You don't need to purchase anything, you just provision the services and you just pay for the consumption from that point onwards, right? So it makes the process of provisioning and deprovisioning applications extremely agile. And like I said, consumption-based model, so therefore you only pay for what you use and when you use them. Private cloud is where an organization has complete control over the resources and their security. I'm not saying that there is no security in the private cloud, but the security model is shared. There's a slide that highlights this later on, but the security is kind of shared between the hosting provider and the customer. The hybrid cloud is the one where you get the most flexibility because you can determine which applications you want to run in your data center and which application you want to run in a public cloud. And that also allows you to comply with the compliance or legal requirements that your organization is subjected to. Now let's move on and look at the various types of cloud services. Now, cloud services are generally divided amongst these three services: infrastructure as a service, platform as a service, and software as a service. Right? So infrastructure as a service is the one that I guess most customers or most users are familiar with. It's the most basic category in cloud computing. And what it really is that it's like as if you are paying a service provider to host your VMs, right, on your behalf. So it is it could be you renting an entire server and placing that server within the hosting provider's data center. It could be you renting an entire rack of servers, or it could be you just subscribing to a virtual machine and allowing the virtual machine to run in the hosting provider's data center. So that's the concept behind infrastructure as a service, right? So you will then go into a self-service portal and you will then be able to key in all the information pertaining to the servers that you want to create, and the resources will then be provisioned in the backend in the hosting provider's data center, and you will then be able to access your resources. So we will typically then subcategorize IaaS into three subcategories: compute, storage, and networking. Because typically when you create a VM, the VM needs to be connected to a virtual network, right? And the VM files, the VHD files, if it's Microsoft virtualization, are then stored within a specific storage account, or a storage solution. So that would be the storage account on the cloud. So we have the storage services, we have the networking services, as well as the compute services, which are the virtual machines, right? So that's infrastructure as a service. Platform as a service is where you have, well, in a nutshell, a platform that allows you to build your solutions. A good example here would be the Azure Web Service. If you're talking about Azure. And this is basically a web service hosting platform. It consists of a virtual machine, which could be running Windows or Linux, but to simplify my discussion, I'm just going to say that it's a virtual machine running a Windows operating system, and let's say Microsoft Internet Information Services, which is a web service application. And that platform is pre-created for you when you subscribe to the web service. So what you will then do is that you would then compile your web application, and then you will place your web application or allow it to execute within the web service. So therefore, the platform has been pre-created. You do not have access to the virtual machine or the configuration of the web service application, right? But the applications or the solutions that you have compiled, you can then place them within the platform service, allowing it to operate within the operating environment, right? So at the VM level or the operating system level, or even the middle tier application level like Microsoft IaaS, you have no control over their configuration, and that's generally what a platform service is, right? And finally, software as a service is where you have a complete built-up software, a managed software, where you as an end user can then consume. So a good example here would be Microsoft Office 365, which consists of, among others, Microsoft's email application. So it's a completely built application. So once you subscribe to the service, you're able to use a client tool like your mobile apps or Microsoft Outlook to connect to your service instance and consume the service, send and receive email and so on. And that's basically what software as a service is, right? So again, to compare the cloud services, just remember that they're not the same. Infrastructure as a service is the most flexible, where when you subscribe to an IaaS instance, the service provider is providing you an environment for your servers to run. So for the most part, when we look at cloud services, these servers are virtual machines, right? So you're creating a virtual machine which is placed within the virtual infrastructure, or rather the virtualization infrastructure that the hosting provider is has implemented in their data center, right? So you will then be able to remotely access this virtual machine, and then you have full flexibility in the way you want to configure, the virtual machine, the operating system configuration, the patching of it, the installing of the applications, and so on, right? That's IaaS. Platform as a service is very highly productive because you focus on application development, right? The platform management, the operating system, the VM provisioning is all handled by the cloud provider, right? So you focus on application development using the platform to develop your application and to host your application and to run your application, right? That's platform as a service, right? And software as a service is a subscription model where you pay for a complete built software, and which you will then utilize by using a client utility, right? And that's really the summary of it. So if you want to compare the management responsibility for a customer across these services, right? Let's start by looking at on-premise. So if you look at on-premise, right from the data center implementation, the networking, the storage, the physical server implementation, your virtualization stack, and once you create your virtual machines, the operating systems within them, the middleware, the runtime, the data, and the applications that are going to be hosting within those servers, it all falls under your responsibility. You manage the entire data center, right? But if you look at infrastructure as a service, if you look at Microsoft Azure as an example, when you create a virtual machine, that's an example of an infrastructure as a service instance. And what happens is that Microsoft in the back end, they manage the data center, the networking, the storage, and the physical servers, even the virtualization stack. So when you create an Azure virtual machine, that VM gets deployed by Microsoft in their data center, and you will then be allowed to remotely access that VM, after which you are completely responsible for the OS and everything else that goes into the server, right? As you can see, platform as a service, even the deployment of the VM, the OS and the middleware is handled by Microsoft. So the example I gave you earlier was Azure Web Service, which is powered by Windows and Microsoft IaaS. You also have versions of web service that is powered by Linux. Another example is Azure SQL, where you have a Windows operating system with SQL database service pre-installed, and you will then be able to, let's say, back up your database and restore it into that service instance, after which you'll be able to use your applications that connect to the database, right? So that's platform as a service. Software as a service, you have no control over any of the configuration elements. You're merely a consumer consuming the application and using it. In this example that I gave you earlier was email on Microsoft Office 365, right? So that's what it is. So it's very important for you to understand very clearly what you're responsible for and where the responsibility of the service provider lies. And that brings us to the end of this discussion. So I hope that gave you a bit more clarity on what cloud computing is. As usual, if you have any questions, please post them in the comment section below. I'll gladly address them. We've come to the end of this presentation. Click on the subscribe button for the channel if you find these videos useful. And that's pretty much it. Thank you for watching.